welcome to True Projects. In this video, we are going to explain about the project which is predicting heart diseases using machine learning and different classification techniques. So before getting into the execution first, let's understand what is the project about. So what are these cardiovascular diseases? They are the diseases related to heart. And it is a major global issue that is being caused and it is leading to 1.7 million deaths annually with the heart attacks and also the strokes accounting for about 80% of these fatalities. Countries like Egypt and Saudi Arabia, which are classified as low to middle income countries, they are seeing rise in these disease rates, highlighting need for early detection. So we had some traditional methods to overcome from this problem, but these methods, they are slow and they often rely on specialized healthcare infrastructure, which isn't available always, especially in rural areas. For example, a person is experiencing chest pain may need to travel long distances to access proper testing. So this delay can be life threatening. Therefore, it is essential to develop more efficient and accessible methods for detecting heart disease to ensure timely treatment and improve survival rates. So here where machine learning comes into the picture. This machine learning has a great potential to improve heart disease prediction by utilizing wealth of patient data, that is electronic health records. However, several challenges can hinder the effectiveness of these machine learning models. One of the problem is unbalanced data sets. Unbalanced data set, it means that in the data will be having more healthy patients data than those of heart disease patients data. So the model, it will fail to accurately identify disease signs. And the another concern we have is lack of transparency, is how models make predictions, which can be problematic in healthcare where trust is vital. Additionally, we have problem with the selection of important features. So, this selecting relevant features from large data sets can be tricky. Including irrelevant information can complicate the model and reduce its accuracy. So, addressing these challenges is essential for developing reliable machine learning tools that can identify heart disease risk early, leading to better healthcare outcomes and less strain on healthcare systems. So, goal of this project is to create an accurate machine learning technique for predicting heart disease at an early stage. So here we are focusing on using different feature selection techniques that are chi-square, analysis of variance, that is ANOVA, and mutual information. So in this project, we focus on selecting the most important features using all these three techniques to figure out which patient data points are most important for making these predictions. Once we identify the relevant features, we test out them using 10 different machine learning models. So we test them using machine learning models. By doing this, we can see which technique and which feature subsets work best for diagnosing heart disease. Essentially, we want to find the most effective way to use available data to help identify heart disease early, which can ultimately save lives by enabling quicker intervention. So, to tackle the issue of class imbalance in this project, we are incorporating synthetic minority oversampling technique that is called SMORT. So, this technique helps balance out the data by artificially increasing the number of instances of the less frequent class, which is in our case heart disease. By doing this, we can make our predictions more reliable. Moving on to further improve the performance in this project, we are incorporating ensemble based method as the extension. So, this ensemble method combines predictions from multiple individual models. This helps us to create more robust and accurate final prediction. Here we have incorporated stacking ensemble based classifier. So here in the stacking ensemble based classifier, boosting decision tree, extra tree along with the light GBM are combined, and this model has shown the best performance among all the models built. On top of that, we have built front end using Flask framework. So this allows for user testing and includes user authentication for added security. This is really important because it not only makes the application more secure but also enhances the overall user experience. The goal with this extension is to make the heart disease predictions more accessible and user friendly, ensuring that people can easily input their symptoms and get reliable information quickly. So, moving on to implement this project, we have followed these steps. So, let's get to know what are these. So, first, we have imported the required packages to implement the project, and then we have explored the heart disease data set to know the structure of the data set. And then we have done the data pre-processing. So here we have cleaned the data and then we have dropped unwanted columns. After that, we have visualized the data using correlation matrix and sample outcome graph. Then we have converted categorical data into numerical by using the label encoding technique. Then we appended all the features to X variable and target to Y variable. Then we have used smooth technique to address the class imbalance, and then we have selected features using three individual techniques. One is ANOVA, chi-square, and mutual info. So for complete entire data set, we have used first ANOVA technique. We have selected relevant features. Then we have built all the models on this particular data set, this particular feature selection technique. And then we have used chi-square to select the important features. And then after selecting important features from the data set, on those features, we have trained the data set. Then we have used mutual info technique. So here also we have selected important features using mutual info, and then we have trained all the models on the selected features of mutual info technique. Then we have split the data set into train and test, where training set is used for training the models, testing is for evaluating the models. Then we build the data set, build the models, and we train them. We compare them using accuracy, precision, recall, FN score, and AUC. Then we compare them using the graphs. So we also have developed front end using Flash framework. So after developing Flash framework, I mean after developing the front end users, they will be able to give the inputs using their feature values. So those feature values they will be pre-processed at the back end, and the train model, that the train machine learning model, will be used for predicting the result. Finally, outcome will be displayed through front end whether the person has heart disease or not. Moving on, in this project, we have used all these algorithms, which are Naive Bayes, Support Vector Machine, XGBoost, AdaBoost, Bagging Classifier, Decision Tree, K Nearest Neighbor, Random Forest, Logistic Regression, Voting Classifier, and the Extension Model Stacking Classifier. So this model has achieved the highest accuracy among all the algorithms used. So we have used it in the front end to detect the heart disease. And to implement this project, we need basic hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So now let's execute. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let's understand each of them, how will they be used in the project. In this archive file, we have the dataset used. So let's open it. So here we have heart disease dataset. So this is the dataset that is used in the project. And here these are all the independent variables that impact the heart disease. So based on these, we'll be predicting the heart disease. And here finally, in the last column, we have the target variable in which we have two classes, 1 and 0. 1 refers to the person who have heart disease and 0 refers to the person who don't have heart disease. So this will be impacted by all these independent features. So we'll be using this data set to train the models. Let's close it, get back. Here in this models folder, we have algorithmic information, and this will be loaded into the project code during runtime of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Next one, we have is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here we have three notebook files. So here we have ANOVA, chi-square, and mutual info Jupyter notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here in this ANOVA Jupyter notebook file here, from the data, features will be extracted through ANOVA and the models will be trained on the ANOVA extracted features. Similarly, for chi-square and mutual info. And this is the, here we have the sample ANOVA file. Let's open it. So these test cases, I mean, these are the test cases using which we'll be predicting the heart disease in the front end. So these are the ANOVA extracted features. Let's close this. Similarly, we have in chi-square and mutual info. And here we have signup.db file. This is the database file which is used to store the user information. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Open that. So using the command cd followed by the space, paste the copied path and now click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py using Python space app.py. Now click on enter. This command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any website. So I'm copying this. So here we have to open browser. So let's open it. Paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now let's register. So click on register. And here we need to we need to enter all these details and then we'll be able to register. If you are a new user, you have to register or else you can directly log in. I am already an old user, so I'll directly log in. So click on login, give username and the password, click on login. We have logged in successfully and we are redirected to prediction page. So as we have selected features using three different techniques, here we have made prediction for the three different techniques. So first we'll be doing prediction for the ANOVA extracted features. So we will be giving input to the ANOVA extracted features, similarly to the chi-square and also the mutual info. So now let's click on ANOVA. Here, these are the inputs need to be given for the prediction purpose. Let's understand all these parameters. What are they? So first we have is sex, that is the gender of the person. And next we have is CP, it is chest pain type. This refers to the type of chest pain experienced by the patient, that is categorized into two different types that helps assess heart conditions. And next we have is Talash. It is the maximum heart rate achieved. This measures the highest heart rate reached during a stress test, providing insights into the heart's capacity to respond to the exertion. Next one we have is exang, that is exercise induced angina. This indicates whether the patient experiences chest pain during physical activity, which can signify underlying heart problems. Coming to old peak, this represents the repression of the ST segment in the ECG induced by exercise relative to rest, serving as a marker for heart health. Coming to slope, this describes the slope of the peak exercise ST segment, which helps in assessing the heart's electrical activity and potential issues. CA is number of major vessels. This indicates the number of major coronary vessels colored by fluoroscopy, providing insights into coronary artery disease severity. The last one is TAL, that is thalassemia. This refers to the blood disorder that affects hemoglobin, and in this context, it indicates the presence of thalassemia and it is potential effects of the heart health. It is potential effect on the heart health. So now let's enter all these parameters. Let's give input to all these parameters and then predict. To give these inputs, let's open the sample file of ANOVA. So let's open the sample file of ANOVA. So let's consider the first test case. So here the gender is male. So we are giving value as 1. Here we have to give the CP as 0. Talash value is 171. Exang is 0. Old peak value is also 0. Slope is 2. CA is 2 and Thal is 7. Now click on predict. It's buffering. So this input will be pre-processed at the backend and then train model will be giving the prediction. So here we got the prediction that patient has report of negative. That means patient is not suffering with any other heart disease. So let's try by giving the other test case. for the same data set, for the same feature selection technique. So click on ANOVA. Let's try using the second test case. So the gender is female. Here we are supposed to give the CP. Next one is Talaj. Next is Exang, Old Peak, Slope, CA, and Thal value. Now click on Predict. So here we got the prediction that algorithm is being predicting the patient's data as positive, which means patient is suffering from the heart disease. So with the given input, when it is pre-processed and fit with the trained model, it is giving the prediction that patient is suffering from the heart disease. So now let's try with the other feature selection technique, that is chi-square. So click on chi-square under prediction. So here we have the first one is age of the person, gender. Next one is chest pain. And here coming to the rest BPS. Rest BPS is nothing but resting blood sugar. This measures the patient's blood pressure when at rest, providing important information about cardiovascular health. The next one we have is cholesterol, that is serum cholesterol. This indicates the total cholesterol level in the blood, which is a key factor in assessing heart disease risk. Next one we have is REST ECG. It is the resting electrocardiographic results. This reflects the results of an ECG while the patient is at rest, helping to identify any abnormal heart rhythms or signs of heart disease. Next we have is the large, that it is same to the last ANOVA feature selection technique, and here we have exang value. We heard about that in the ANOVA feature selection technique, and here we have old peak. We also heard about that. Slope. Slope is, it describes the slope of peak exercise ST segment, which can provide insight into the heart's electrical activity during stress. The next one we have is CA, that is number of major vessels. It is the number of major vessels. This indicates the number of major coronary vessels with a significant narrowing, which is essential for assessing the coronary artery disease. So now let's fill in all these parameters. That means let's try with the two test cases. One is with the positive and the other one is with the negative. Let's try. So for that, we have to open the sample chi-square file. So these are the test cases. So here, let's try with the first test case, that is age would be 58, gender is male, CP value is 0, rest BPS is 125. Next is cholesterol 300, rest ECG is 0, Talach value is 171, exang value is 0. Next old peak value is also 0, slope is 2 and CA is 2. Click on predict. So here if you observe, it has to be predicted as 0, which means that patient should not have any heart disease. So here also we got the correct prediction that patient is not suffering with any other heart disease. Let's try with the other test case. So now let's check with the mutual info feature selected techniques. So click on MI. So these are the mutual info feature selected from the data. So we have heard explanation about all this already with the other feature selection techniques. Now let's directly give the inputs. So for that, we have to open the sample MI file. So let's give the first test case. So this is the first test case where age of the person would be 58, gender is male, and the CP value is 0, cholesterol value is 300, Talach value would be 171, and exang value is 0, old peak is also 0, slope would be 2. The next CA value is 2, and the TAL value is 3. Here it has to be predicted as 0. Now let's check how will it predict correctly or wrong. Click on predict. So here we got the correct prediction that patient is not suffering from the heart disease. Let's check with the other test case. Click on prediction, click on MI. Let's check with the second test case. So age of the person would be 64 and the gender is female. CP value is 325, cholesterol is 154, Talach is 1, Exang is 0, Old Peak is 2. And the next we have to enter is slope. Slope is also 0, CA is 2. We have entered wrong, so let's recheck it. After 154, we have to have Talach as 1, Exang is 0, 2 is Old Peak, slope is 0, CA is 2. Age would be 64, sex is 0, CP is 325. Sorry, CP would be 0 and cholesterol would be 325. Talach would be 154 and Exang value is 1. Old Peak value would be 0. And the next one, slope would be 2. The next CA, it has to be 0. And the tal value is 2. It has to be predicted as positive. That is, the person should have the heart disease. So click on predict. Let's see what will it predict. So here we got the correct prediction that person has a positive report. That means patient is suffering with the heart disease. Now let's check with the graph. So click on graph. Let's check the graphs of ANOVA feature selected graph. So click on that. So here we have sample outcome graph where on x-axis we have the target variable and on y-axis we have count. Here 0 class represents persons with no disease and 1 represents persons with disease. And this is the correlation matrix. This shows the correlation between the variables. And here we have the accuracy comparison graph where on x-axis we have accuracy score of each algorithm and on y-axis we have the algorithms. Here if you observe extension model, that is voting stacking classifier, is having the highest accuracy. And here we have precision score, recall, FN score, AUC. So these are all the error metrics. Using this, we have evaluated all the models. Let's check with the other feature selected technique, that is chi-square. So here we have the graph. So this is the same sample outcome graph, and here we have the same correlation graph. And this is the accuracy comparison graph. This is the precision, recall, FN score, and AUC. So here, all these models are built on the feature selected using chi-square. Let's check with the last feature selected technique, that is mutual info. So click on that. So this is the simple sample outcome graph. Here we have correlation matrix, accuracy, precision, recall, FN score, and AUC. So among all the feature selected, I mean all the algorithms which are built on all the feature selection techniques, if we observe, extension model is having the highest accuracy than any other model. So now click on log out. In this way, by using the feature selection techniques and using machine learning techniques, we will be able to predict the heart disease accurately. So this is all about the project.
.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.